Problem number 7 is another one that looks like we may be able to use substitution with it. However, again, we don't have the criteria that the derivative of either the top or the bottom shows up as a multiplier. So t squared plus 1, its derivative would be 2t. We don't see a 2t there as a multiple, as a factor that we can swap out. And the derivative of the denominator would be 1 over 2 times the square root of t. And so after we swap out the square root of t for u, we don't have another square root of t in there to work with. So in this case, we can't use substitution again. But there's a very simple technique that we can use to break this down. And that would be to take the integrand. You'd have t squared over square root of t and plus 1 over the square root of t. So we can simplify that. We have 1 over square root of t is t to the negative 1/2 times t squared plus t to the negative 1/2, leaving us with t to the 3/2 plus t to the negative 1/2. And so our whole integrand boils down to that. Integral from 1 to 4, t to the 3/2 plus t to the negative 1/2 dt. Alright, so we're going to anti-differentiate. T to the 3/2 becomes t to the 5/2 over 5/2, or 2/5 t to the 5/2 plus t to the 1/2 divided by 1/2, 2 t to the 1/2, and from 1 to 4. So if you recall our strategy, again, we're going to have two expressions here subtracted from each other. 2/5. Now the easiest way to find 4 to the 5/2 is to first take the square root of 4, which is 2, raised to the 5th power, which is 32. Then square root of 4 is 2. 2 times 2 is 4. With the other one, it's a lot simpler. We have 2/5, because 1 to the 5/2 is 1. 1 to the 1/2 is 1. 2/5 plus 2. Alright, so we end up with 64 over 5 plus 4 minus 2 over 5 minus 2, and that would be 62 over 5 plus 2, which would be 62 over 5 plus 10 over 5, or 72 over 5, and that's option A. So again, this illustrates another very important point here about integrands that can be simplified, especially rational integrands. If you have one term on the bottom, two terms on the top, you can split it up into two terms, or if you had three terms on the top, three terms, simplify each term, and then use the power rule. Now, vice versa, if this were square root of t over t squared plus 1, that wouldn't work. We couldn't use that strategy. We can't split up the denominator. We can only split up the numerator. So hopefully that's clear, and we'll leave this one at that.